Hi everyone, my name is Roshan. I work for Codarts Rotterdam as part of the rigging team at the Circus department.
Hi everyone, I'm Matt. I'm a rigging technician at the National Centre for Circus Arts, and we are collaborating here on a FED talk video for FEDEC. So let's begin. The aim of this video is to look at dynamic forces that we generate doing our circus movements. We're looking at how the concept of dynamic forces affects us when we're thinking about the rigging, safety and the selection of the equipment. The video really is aimed at anyone who's interested in rigging safety, be they students, practitioners or teachers.
So Matt is talking about dynamic forces. What is a dynamic force? A dynamic force is a force acting on an object that causes it to vary or change its size, position or direction. So we are looking at what happens when a circus artist does its tricks. This is really important for us to know, because then we can choose our equipment on the right way, so we can be as safe as possible. So for this test, we rigged a hard-rigged setup with a load cell in between, which is going to tell us the forces that's been generated by the artist.
So we have the load cell attached at the top of the artist's equipment. We're going to measure the dynamic forces once they do their moves. We're going to be looking at straps, hoop and silks. We've just set up Eric's straps. We've got the enforcer load cell rigged between the truss and the straps themselves. Eric's warming up, so we're about to do our first proper experiment.
So your body weight is 85 kilos. With the big swing, you became 294 kilos. So now you must know why you're hurting a little bit.
Yeah.
So we have Becki on the hoop, and she made a big move, and that came up to 152 kilograms.
So let's do the maths. We have our aerialist weighing 50 kilograms, which is equivalent to 50 decanewtons. Our apparatus and hardware comes to 12 kilograms, which is equivalent to 12 decanewtons. Combined, they are coming in at 62 kilograms or 62 decanewtons. Add our dynamic movement and the force created comes to 148 kilograms, 148 decanewtons. The equation goes 148 divided by 62, giving us our dynamic factor of 2.4. We have our weakest link in the rigging system with a minimum braking strength of 22 kilonewtons, equivalent to 2,200 decanewtons or 2,200 kilograms. But what is the working load limit? Based on this, on the working coefficients for equipment materials, we can see that the metal components and chains have a working coefficient of 4. Wire ropes is 5, and textile fiber ropes and straps is 7, but we're worried about the steel work. So our equation is our minimum breaking strength 22 divided by our working coefficient for metal at 4, giving us a working load limit of 550 decanewtons or 550 kilograms or 5.5 kilonewtons. So our aerialist, who is coming in at 148 decanewtons, is well within our working load limit. So it's okay for Circus.
Thank you so much for watching. We really enjoyed making this video on dynamic forces, on how it affects your body and the equipment we use.
And a massive thanks to FEDEC for giving us this opportunity, and another massive thanks to the National Centre for Circus Arts and Codarts in Rotterdam.
If you want to know more on this, please look at the links below in the description.
And check out the FEDEC website for more Fed Talk videos. Goodbye and thanks.
Dankjewel en tot ziens.